Hey guys, welcome back. Today is day 56 and we're going to talk about solving a quadratic equation. Now the standard form of a quadratic equation would be in the form of ax squared plus bx. Oops, not sure what happened there. Let's write that again. Ax squared plus bx plus c. Okay, now when we were working with quadratic equations when we learned to factor them, only now we're going to take this and set it to 0. So we're actually going to be solving for x, okay? So a lot of times a question will ask for you to solve the equation, find the zeros, find the x-intercepts, find the value of x, find the roots, find the answer. This all means the same thing, okay? What a quadratic equation is, it actually makes the shape of a parabola, okay? If you graph it, and if you graph that parabola, okay, the solution would actually be where that parabola crosses the x-axis. So you can see with the example I just wrote, it crosses it in two different locations. Okay? Sometimes our solutions will have two solutions. Sometimes if the parabola is graphed and it just touches in one place, it's not a very good example, but say it went down there and touched right there, that would be one solution. And then sometimes if you graph, you'll actually get a case where well, there's two. Okay, I did it backwards there. But if you did it, say something like this, where you were down here and it never crosses the x-axis, that would be no solution. Okay, we're going to be talking about that. I know it's a little confusing there. Okay, but we're going to start with what we did last unit where we learned how to factor. So we're going to start by taking the factors and setting each one of those factors to 0 because the zero product property tells us that if either one of the factors is 0, then the entire equation would be 0. So if I took 4 times 0, I would get 0. Okay? All right, so anything times 0 is 0. All right, so when the equation is true, if x plus 3 and x minus 5 equals 0, we can take each one of those factors and set it equal to 0. So we could take x plus 3 and set that equal to 0. And we can take x minus 5 and set that equal to 0. And when we do that, a simple one-step equation would say that x is equal to negative 3 and x is equal to 5. So our solution set, we'd have two answers, negative 3 and positive 5. And notice we list this in a solution set, which would be the curly brackets. Okay, it's not an ordered pair. All right, so we're going to show some examples first. Okay, so if I had x plus 7 times x plus 12 is equal to 0, all I'd have to do is set x plus 7 equal to 0 and x plus 12 equals 0. Okay, simple one-step equation. Our x is negative 7. All we did was subtract 7 from both sides, and in this case our x would be equal to negative 12. So our solution would be negative 12 and negative 7. I typically like to start at the lowest number and increase when I list a solution set. Okay, the second example, if I had 2x plus 3 and I set that to be 0 and x minus 5 and set that to be 0, on the left I would get a two-step equation. So 2x would be equal to negative 3 and then I would divide both by 2 and my x would be equal to negative 3 halves. Okay, on the right side we add 5 to both sides and we would just add 5 to both sides and we would get x is equal to 5. It's not erasing very nice for me right now. Okay, but x would be equal to 5. Okay, we just added 5. So in that case our solution set would be negative 3 halves and positive 5. All right, you can also see that as a decimal, negative 1.5 and 5. All right, and sometimes the decimal form, it's a little easier to envision or look at the graph in Desmos and see that it's actually crossing the x-axis at negative 1.5. Okay, so here's some examples where we actually took a snippet of the graph, and you can tell just by looking at the graph in this particular example that this parabola crosses right here and here. So the actual two solutions would be negative 3 and 2. Okay, but let's factor the equation and let's see if we discover the same thing. So I'm going to factor it. Notice I'm already in standard quadratic form. So my a is 1, my b is 1, and my c is negative 6. Okay, so when I make my x to help me, a times c is negative 6, my b is 1. The two numbers I can multiply to get negative 6 that add up to 1 would be 3 and negative 2. And then I would divide by the leading coefficient. So to factor, I would have x plus 3 times x minus 2. And to solve, I would set both of those factors to be 0, okay? Although the zero product property says that just each factor needs to be 0. So we would then solve. X plus 3 is 0. Our x is negative 3. And x minus 2 is 0. Our x is 2. Okay, so notice, again, our solution is x is equal to negative 3 and 2. All right, so once we factored, we had 3 and negative 2. Notice, factoring and then solving, you actually get the opposite sign. So instead of positive 3, we have a negative 3, and then instead of a negative 2, we have a positive 2. And that happens because we're setting them equal to 0. All right. So number 4, if I look at my solutions, the graph is cutting through here and here. If I count, it looks like it's at negative 6 and positive 6. All right, I'm going to factor x squared minus 36, and since this is the example of the difference of perfect squares, we can say that this would be x plus 6 and x minus 6. And since we want to set them both to be 0, we can see x plus 6 is 0, so x is negative 6. And x minus 6 is equal to 0, so x is positive 6. So that verifies our solution. We did it by looking at the graph, and then we also factored it. Okay? All right, so if I looked at number 5, notice the graph never touches the x-axis. Here's our x-axis down here. See how it's way above it? All right, this is an example of no real solution. Okay? And the reason we're going to call it no real solution is because we use the real number system. Okay, there's something called the imaginary number system that you'll get to in Algebra 2. But right now, we know that there's not going to be a real solution. All right, let's see what happens when we try to factor this. Our A is 1, our B is 1, and our C is 3. Okay, we have A times C is 3, and then we have a 1. Notice, okay, that polynomial we can't factor. It's actually prime. All right, so the graph will show that there is no solution or no real solution. All right. All right, number 6, if we look at the graph, we notice it just touches down at 1 point. And the 1 point, since this is 0 and 4, if we look at the scale, it's actually going to be this is going to be a negative 4. In between the two would be a negative 2. So the one solution would be negative 2. Let's start by factoring it. Our A is 1, our B is 4, and our C is also 4. There's that weird line again. All right, 4 times 1 is 4, and then the B is 4. The two numbers that we can multiply to get 4 that add up to 4 would be 2 and 2. Again, we divide by the leading coefficient. All right, so if we took each of the factors, x plus 2 times x plus 2, and we set that to be 0, we can see x plus 2 equals 0. Our x would be equal to negative 2. And since it's the same factor on the other side, it's also going to be x is equal to negative 2. And that's how we get our one solution. All right, so if the equation is not already factored, then you must factor first. And it's very important that you get it into the standard form. Okay, really important, which means you might have to move some things around to get it into that form. In example number 7, we don't have to move anything, but our A is 1, our B is negative 9, and our C is 18. Okay, A times C is 18, and then we have a negative 9. The two numbers we can multiply to get 18 that add up to negative 9 would be negative 3 and negative 6. We divide by the leading coefficient. Okay, so here's our two factors. We've got x minus 3 and x minus 6, and they both can be set to 0 with the zero product property. So x minus 3 would be equal to 0, and x minus 6 would be equal to 0. In this case, x is equal to 3, and x is equal to 6. So our solution is x is equal to 3 and 6. Notice again, our solution is opposite of our factors. Okay? Now number 8, notice the first thing we want to do is always factor out our greatest common factor. So in the event that you don't have a constant, okay, meaning there's no C value, you're going to be able to factor out at least the x. In this case, you can factor out a 5x. Okay, and you still have your two factors. It's just that using the zero product property, now you're going to set 5x equal to 0, and you're going to set x minus 8 equal to 0. Divide both sides by 5, so your x is 0 and your x is 8. Okay, so your two solutions would be 0 and 8. Okay, if we looked at number 9, now if the equation is not set to 0, you have to set it equal. Again, get this into standard form. So you're going to bring the 5x to the other side of the equation. So I'm going to have a negative 5x plus, whoops, I don't want to do that here. It's going to be x squared minus 5x equals negative 6. Now I bring the negative 6 to the other side by adding 6 to both sides. So in standard form, I've got x squared minus 5x plus 6 is equal to 0. Okay, now I can identify my A, my B, and my C. Okay, you can't do that until it's in standard form. Okay, A times C is 6, our B is negative 5. The two numbers we can multiply to get 6 that add up to negative 5 would be negative 3 and negative 2. Again, we divide by 1, the leading coefficient. So when we factor this, it's x minus 3 times x minus 2 would be equal to 0. We set each one of the factors to 0. X minus 3 is 0. And we get x is equal to 3. And x minus 2 can be 0. And in that case, x is going to be equal to 2. So our solution is x is equal to 2 and 3. Okay. Same with number 10. We want to put this in standard form. So I'm going to start by subtracting x from both sides. All right, when I did that, I got 2x squared minus 7x is equal to negative 3. Now I'm going to add 3 to both sides. 2x squared minus 7x plus 3 is equal to 0. Okay, from here, we identify our A is 2, B is negative 7, and C is 3. Okay, A times C is 6, and then we have our negative 7. The two numbers we can multiply to get 6 that add up to negative 7 would be negative 6 and negative 1. Okay, and we divide by our leading coefficient, which is 2, and simplify. So factoring, we've got x minus 3 and 2x minus 1, and we set them both to 0. X minus 3 is 0, so we get x is 3, and 2x minus 1 equals 0, so 2x is equal to 1, our x is 1/2. So our solution is x is 1/2 and 3. Again, the opposite of what we factored. Okay? All right, so to solve a quadratic equation that does not have an x term, meaning that middle term, ax squared plus bx plus c, okay, if there's no middle term, okay, and we set it to 0, we can just rearrange and solve directly for x by using the square root. Okay, what does that mean? It means we're using the golden rule of algebra to get x by itself. So I'm going to start number 11 by dividing both sides by 2. X squared is equal to 4. Okay, the inverse operation of squaring a number is to find the square root. So if I want to get x by itself, I'm going to take the square root of x squared, and whatever I do to the left side of the equation, I do to the right. I end up with x is equal to not only positive 2, this is the first time we're going to really think about it, the square root of a number, 4, would be positive 2, but it would also be negative 2 because negative 2 times itself, meaning negative 2 times negative 2, is also positive 4. So we actually have two solutions, and we write that sometimes as plus minus 2. All right, but in set notation, it would just be x is equal to negative 2 and 2. All right, so there's an example that our parabola would have two solutions, okay? Number 12, so the parabola rather would cross the x-axis in two places, so our quadratic has two solutions. Number 12, when we add 18 to both sides, we end up with x squared is equal to 0. Well, the square root of 0 is just one number, it's just 0. So x is equal to 0. So that's going to be our solution. Okay, we just have one. All right. Now the third example, if we subtract 12 from both sides, we end up with x squared is equal to negative 7. Well, what happens with the square root of a negative number, we don't have a solution. You cannot take the square root of a negative number. You'll get an error on your calculator. So we're going to say that x is no real number, okay? And we, again, because or no real solution. Because there's no real solution, there is something called an imaginary solution, but we'll talk about imaginary numbers in Algebra 2. So it's no real solution. So if we actually graphed, might look something like this, where it's never touching the x-axis. That's when we have no solution. Okay, so highly recommend that you get your homework done, okay, and do the practice problems, and make sure that you can also go out and do the exit tickets that's out there as well. Okay, bye.